So now that we had the trick from the other one, the triple cut's actually going to be a lot easier than it seems. What we're going to do is that we're going to take this triple cut method and we're going to use temporary lists to swap everything. So suppose we have a linked list of integers with two items we'll call jokers in them, denoted by J in our example. Write an instance method called triple cut, which swaps everything above the first joker with everything below the second joker. For example, if our list is this, then note after triple cut, notice that all the items over here, 3, 9, 8, and 2, are now in the front of the list, and 1, 4, 5, 2, 6, 2, 6 come after this one, right? So, and I can assume that all the elements in the list have are integers. The list has two jokers, and that the jokers have the values 53 or 54. Now I'm going to do this one in Genie or in gedit simply because this is one of those things that are easier to write on an exam than to try to get working in the linked list code that I currently have. So, because we're assuming we're dealing with integers just to make this easier for us. Okay? So, we'll go ahead and start this. And what we're going to do is we are going to go ahead and use temporary linked lists again. So I'm going to do a doubly linked list. You know what? It's we're going to assume that we have a singly linked list, but you can use it. I'm just going to go with linked list L is equal to new. I'm going to assume we're working in linked list. Okay? You're allowed to assume which class you're working in unless I otherwise specify. Linked list, and these are integers we get to assume. So linked list of integers, we're assuming we're working with a linked list. Okay, this is a bit why it's messy. You know, it occurs to me I could have had this done as a static method, but you know, if wishes were fishes. It's the algorithm that matters more. Here. So temp. So we're working inside of a linked list and we want to do a triple cut of this. Temp left, temp, or rather temp top of the deck, temp bottom of the deck. I'm saying deck here because really what this is representing is a deck of cards where every card has been encoded into a value, like ace of hearts is 1, 2 of hearts is 2, 3 of hearts is 3, and so on and so forth. And then each suit as we go up, it's now a different multiple of 13. Well, not multiple of 13. We just add onto that. And the joker, so there's 52 cards, and jokers are cards 53 and 54. So this, by the way, is part of what you'll need to do for your triple cut. Oh, sorry, for the extra credit assignment. Okay, so I'm going to keep going on with this one. Okay, so I'm going to create a node. Yeah, this is definitely going to be, not want to be a static method. Node e current is equal to new is equal to this list head. Right, or rather, since we're dealing with a linked list of integers, we can, right? But honestly, the only reason this won't work is because your code is assuming your e's, and then you'd have to cast everything left and right. Again, this is why it works so much better on paper as a question than it does on an actual compiler. Okay, so while current is not equal to, so rather than doing head or tail here, okay, rather than doing like while current is not equal to null, instead what we're going to do is that we're looking for the joker. So while current is not equal to 53 or current is not equal to 54, what are we going to do? Well, at the end of this, we're going to want to, at the end of this line, we're going to want to do current is equal to current.next. Hang on a second, this kind of bugs me when I don't have Here we go. Color. Current is not equal to 53 or 54. First thing I want to do is do, let's see. So now we're going to just basically remove. Actually, I don't need to do current is equal to current.next. There's a bunch of ways I'm doing this, and I'm thinking about the way to do this now because I knew in my mind theoretically how to solve this. I've had a while to think about how to solve this, right? But it's the implementation that I'm trying to think about the most efficient way, right? And all you really have to do is, temp top. Possibly not the most elegant way to do this. We might touch this up later. Temp top dot add this dot remove this dot remove index 0. I'll figure out how to do the other one in a bit. Temp top dot, and then let's see, and then we advance. Current is equal to current dot next. Okay. And yeah, so I think actually the easiest way to do this is to be ridiculous about this, and I will also have a temp middle, because we're going to split it up into 3 sections: the top, the middle, and the bottom. That's the easiest way I think to go about this, right? So what we do is that while the current is not equal to 53 or 54, we go ahead and remove the top card of the deck and add it to the temp, to what we call the temp top. So that's going to correspond to all these cards over here. And then we get over here to the Joker. Okay? And we don't really need to do current is equal to current.next over here. What we need to do actually is just say current is equal to head. Just keep saying that, weird enough as that is. Right? So the head kind of so the current kind of becomes unneeded. Head. Head. Boom. Yeah, that looks a lot cleaner. Okay? And now the next part is that we're going to move everything from this Joker to the next Joker. Okay? So now we know we're at a Joker because the while loop stopped executing. So doesn't matter which one we're at. Temp middle dot add this dot remove is the head of the list again. Okay, and then we're gonna just repeat this loop again. Right, while the head is not equal to a Joker, we're gonna find the other Joker, and we're, instead of adding it to the top of the deck, everything from the top of the deck is instead of going to the temporary top, we're going into the temporary middle of the deck. Right? Boom. Okay? So we're just slowly removing all the cards from the deck. Okay, so then we get to the Joker. We'll go ahead and add that into the middle section as well. And now we're left with basically the temporary bottom part of it. And since we're removing all the since we have a temporary bottom, we don't really need it. But since we're going with this paradigm anyway, we might as well do that. I might, again, clean it up at the end. So while the head is not equal to null, in this case, add everything to temp bottom. Alright, and now since we're dealing with a linked list, and so a big thing that you should be working with is that you're assuming you're working with, like, you can assume you're working with a Java linked list, and that I've added everything that would be in the list interface over here. Okay, So method that you should because never tell students they can't use this method. And I've seen students just use it again and again on exams. In fact, a student using it on an exam was exactly how I found out that this was a thing. We're going to use the add all method. Okay, so then this dot add all, because otherwise I'll have to deal with a lot of loops again. This dot add all temp bottom, right? We're gonna take all the bottom stuff, all the bottom cards, move to the top. This dot add all temp middle. This dot add all temp top. In fact, I will go ahead and as soon as I top, that is it. So in fact, rather than clean this up before I completely forget about it, I'm going to go ahead and do you a favor. I am going to go ahead and add the add all method to the back of to the second page of your exam so you don't forget about it.